Cameron, you're doing great, buddy. It's your birthday. You're doing a good job. However, we are still going to talk about arcs and chords today. How are arcs of circles measured in relation to central angles? Starting with what the heck is a central angle. Our learning goal is to apply properties of arcs and properties of chords. We're going to talk about central angles, arcs, minor arcs, major arcs, semicircles, adjacent arcs, and congruent arcs. I'm moving on. A central angle. A central angle is an angle whose vertex is the center of the circle. Okay? Central angle is an angle whose vertex is the center of the circle. Circle. Here is a central angle. Really simple concept. Okay? If two radii meet, they form a central angle. If two radii meet, they form a central angle. So here I've got, what are the radii? Somebody name them for me.
A, B, C.
A, B, and CB, right? And they form angle ABC. That is a central angle. So,
what if you had a D on like the top and the D came in to meet B? Would that be enough?
you now have CB and DB that form angle CBD. And you also have, well, let's just pretend that this is a better drawn circle. Let's say it was a diameter.
That would be good.
Yep. And a diameter is a chord, but it is also still two radii meeting together. It forms a central angle of 180 degrees. So cool. Okay, anyway. An arc is an unbroken part of a circle consisting of 2 points called the endpoints and all the points on the circle between them. Really lengthy definition for something that's not that difficult. Guys, here is an arc. An arc is the distance, the measurement along the rim of the circle. So AC is an arc. Ma'am, you have arc AC. Where are you going? Sit down. AC, you also have, we just talked about angle ABC. Arcs, angles. Arcs are on the rim of the circle. Angles, center of the circle. Yes, ma'am.
So, like, if you knew
That's a long
the
definition.
measurement if you knew like angle, frick, you knew, frick, what's the word? How many degrees
Yes.
angle ABC was?
Yes, ma'am.
And how many degrees angle DBC was?
Yes, ma'am.
How could you use that to find AC?
Let's talk about it.
Oh, can you go back?
Okay.
I got like one more word.
I'll go back in the end. All right. We'll get to what we call the arc addition postulate. It's the exact same as what we've done earlier. This is also another thing that we're going to learn is called, well, the measurement of central angles. We can add those measurements together to form or to get the measurement of other angles. All right. Minor arc is an arc whose points are on or in the interior of a central angle. A major arc is an arc whose points are on or in the exterior of a central angle. Okay? Really and truthfully, difference between minor arc and major arc, it really would tell you more about whether you go along the central angle or if you go opposite the central angle. Here's what I'm saying. If I wanted to know measurement AC, I would be going along the central angle, along central angle ABC. If I wanted to know the measurement of major arc AC, I'd be going this way. A to D to C. Okay? Think about it like this. Minor, when you hear the words major and minor, which one's typically is associated with bigger? Major. Is this going to take you more or less of the circle to get from A to C? Mr. Haynes, more or less of the circle to get from A to C?
More.
More. That's why we call it the major arc, right? That's why it's saying. Better hurry. Right? Also, we got a semicircle down there. Make sure you understand it. Hello? Okay. Circle down there at the bottom. Guys, a semicircle is just the diameter. It's half of a circle. So if you have a semicircle, you've got a diameter. You know that. You've got a diameter. And you've got, so E to G in this case would be half of a circle. Let's get something down right now.
Okay.
How many degrees are there in a circle? 360 total degrees in every circle. How many degrees would there be in a semicircle?
100.
Perfect. Semicircle, semi means 1/2. Okay, so half of a circle is 180 degrees. So far, yeah, it should be simple. Real simple so far. Yeah, and it's going to be easy pretty much the whole day. Practice during that day.
It's like
Promise you that.
Saturday from 7
Okay.
to, like,
Circle grass shows the types of grass planted in the yards of one neighborhood. I highly recommend Bermuda or Zoysia in this particular area, okay? The fescue typically sometimes can make it through the winter. Do not have centipede grass, not in this climate, okay? Number one, it's too clayish. Number two, particularly in the Piedmont area where we are, you're not gonna get enough rainfall in the summer months, so it's gonna dry up. It's gonna lead to weeds, it's gonna lead to moss, all sorts of stuff that you're just not gonna want in your yard.
Yeah.
Bermuda's the
Take
best
it from
grass
me.
to get
Yeah.
right now.
Around here, probably Bermuda grass, especially the Scots Southern Bermuda grass, okay? Requires a little bit less watering all through the winter. That's my science application today. All right, here we go. Find the measure of KLF. All right, I'm not even going to go over this one. I'm going to show you this. KLF would be, let's see here, KLF, we would take 360, we would subtract out whatever 65% of 360 is. Oh, hot dog, it's 126. You get 234. This is more along the lines of what you might see, okay? All right, so all those things are written in percentages. You're not going to see them in degrees. You know why?
Why, Mr. Ross?
Well, because you've got to change them from percentages to degrees. So let's do a little thing here. What is 25? What's 25% of 360?
0.25. Ain't it times 3?
Yep,
What's 90%? Or
90.
90. What? Degrees, right? 90 degrees. Okay, 90 degrees. What is 3% of 360?
10.8.
Wait, 3%? 10.8.
Oh,
Good. 10.8.
that's what I said. But I didn't.
Okay. What is 10% of 360?
36.
All right. So we could go on and on and on and on with that. All right. But understand, all you're going to be doing here in this case, if you want to define the measure of FMC, you'd have to take all of those degrees and add them together, and you'd have your central angle measurement, okay? To do that, you're going to have to take 3 plus 9 plus 10 plus 11, which is not 30%. Oh, yeah, it is. Okay, it's 9, 10, and 11. Sorry. 9, 10, and 11 would be 30% of 360. 30% of 360 degrees they're saying is approximately 108 degrees. Okay? Really, this is just a fancy way of telling you guys, hey, what is 8% of 360? Okay? What is 15% of 360? What's 25% of 360? And so on and so forth. Alright. Well, we're going to move on to better things, though. Adjacent arcs are arcs of the same circle that intersect at exactly one point. R, S, and ST are adjacent arcs. Okay? Now, the only reason why that's important is because it sets up our arc addition postulate. So, if I have two arcs that are right next to each other, you know what? I'm going to slow down and make sure we get this. Does everybody see that arc RS and arc ST are right next to each other? You'll see that? Okay? So if you were walking on the moon, because the moon's circular if it exists, alright? You're walking on the moon, and you go from R to S, and you keep going that same direction, do you see that the next steps you take are going to be along ST? Got me? Okay? Alright. What you can do is, you can add those arcs together. And that's how you get your arc addition postulate. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. Okay? So, check it out, y'all. Let's say you're on the moon, and Neil Armstrong, is he still alive?
Yes.
Neil Armstrong wants to know, hey, what was the total distance from R to T? What's the total arc measurement, I should say, because that distance is different. What's the total arc measurement from R to T? You can tell old Neil, hey man, take RS and add it with ST.
He's dead. He was dead in 2012.
Oh, see, I thought he was dead.
Come on, Mr. Hobbs.
His ghost. The ghost of Neil Armstrong.
Lives on the
That's
moon.
kind of messed up.
I thought you said Wayne.
Why not?
He's alive.
I thought you and him were like best buddies.
What?
Neil? You try real hard, Trotsky. You know that? Alright, you can add those arc measurements together. Let's try it here. Find the measurement of arc BD. Alright.
Dang it, didn't even get the definition.
Go back.
No, I will in just a second though.
Is it okay?
Alright. So check it out. There is one piece of information that you need to know,
What is that?
and it's going to make life a lot easier for everybody. Here's what you need to know. Central angle measurements, AFE, are congruent to the arcs that form them. True story. Remember I told you, let's go, we gotta go back to the beginning. I told you that central angle measurements were when two radii meet, right?
Yes.
What are the radii that form this angle measurement? AF and FE, correct? So here's what that means. That means the measure of arc AE is 97.4. Okay?
Okay. Yeah.
All right? That's why I teach it with that definition. Radius form central angles, and the arc measurements are congruent to the central angles. All right? Everybody with me? So basically, when it asks me to find BD, let's go this way with it, B to D, okay? To find B to D, guys, all I need to do is take the measurements of the arcs that are along it, BD or BC and CD, or I can make it really easy on myself, okay? And I can figure out what the heck these angles are down here. We got one angle right off the bat. 97.4 is a vertical angle with BFC, so that's 97.4, okay? And then you're going to get to play our game again.
We're playing a game?
Yeah, we are.
What game's that?
Cameron, how many degrees are in a semicircle?
180.
True or false? AC is a semicircle. True. And you said there's 180 degrees, right?
So ABC.
So 180 minus all of that would be what?
Wait, let's see, 80 degrees. 82.6.
120. 128 Yes, 128.
Negative 30.6.
How? Wait, if it's a flat line, then you just take 97.
Listen up.
It's
Listen up.
97.
Listen up.
180.
I start. You're right. It would be zero the way I phrase the
It's
question.
97.4 plus.
What I want to know is what would this angle be down here? Okay. And this angle measurement is 180 minus 97.4 minus 52, and that's 30.6. Okay. So as they worked out here, if I simply add together the central angle measurements 97.4 and 30.6, I will get the entire arc on the outside. B to D would be 128 degrees right here.
Wait, but how do you know A to C is a flat line?
Ah, great question. How do I know? Let's go back.
Yeah.
Let's go back here. How do I know that AC is a diameter?
It goes through
It goes through the what? We call it the center of the circle, right? F is the center of the circle, but the big red dot. It's red to me, okay? If AC goes through that dot, that means it has to be a diameter.
Yeah, but how?
It's a chord that goes through the center of the circle. All chords going through the center of the circle are diameters. So do I have another diameter here? What is it?
E, D, or
BE is another diameter here. Yes, ma'am.
How do you know the AC is a chord and it's
Yeah, that's what I was gonna say. How do you know it's not AF and then FC?
How do I know it's not AF and FC?
Yeah, like there's.
Like, how do I know that AF and FD, how do I know that's not a diameter?
Yeah,
Is that what you're asking?
like
how do you
there's no proof. What if it's like
Is AC a chord?
it looks like it, but there's no like absolute proof.
how do you know for sure? Just like go crazy. Because you keep saying don't look, but based on
No, because what if it's going straight? What if like AF?
So
is
what if
going
it's
straight?
off by a single degree?
Yeah,
You're
you're gonna screw us over. Like
Yeah,
that.
I would completely mess you up. No,
Please don't
it's,
do that.
I won't do that. That's
If
that's
it
how.
looks like at least
I
make it
promise.
look different.
In 10th grade math, we're not going to do that to you. Maybe your sophomore year of college, we'll get something like that. Okay.
Okay.
Probably not going to do that to you now. I see what you're saying now. All right. Let's go. Let's do another one. Is it apparent that we have two chords here
Yes.
that are diameters?
It looks.
We don't have to do the look thing, man. All right. Yeah. Anytime you see chords going through the center of the circle, you have a diameter.
Is it
Right.
just me or does that dot look off?
It's just you. It looks off.
Completely just you.
It
Okay.
looks off.
It just
I
looks
think-
off.
So if I want to find,
Yeah.
if I want to find the measure of JKL, I want to find the measure of JKL. Let's talk, y'all. Do you see the vertical angles here? Good.
Wouldn't
So that means that this is 25 degrees. Now, here, I guess, you know what? If you want to prove it, if you two aren't satisfied, you want to prove it,
no?
you can.
I don't want to.
Take 180, subtract 40 and 25, and what do you get?
25.
No. 180 minus 40 minus 25. 115 degrees, right? So, Mr. West,
That equals 180.
is 25 plus 115 plus 40 180?
Yes.
That means that this is the diameter, right?
Yes.
Okay, good. Okay, so what would JKL be? What would be the measure of arc JKL? We're talking about that. What do I have to do, y'all?
You gotta add.
Add what? And what?
25.
What do you get?
Hang on. 115. I got freaking 140. I like doing the work.
Right on. Alright. I could do it another way if I wanted to go LJN. Alright, I got a question for you guys. L to J to N. Mr. Haynes, is this a minor arc or is this a major arc? Very good. Okay. Very good. Yeah, that's gonna come to you guys. Y'all get this, right? You're going from L to N, right? But if you take the long way from L to N, that's a major arc.
So if it's bigger.
Could I go the other way?
Yes, make it a minor arc.
There you go.
So,
So,
major is like taking the long way, and then minor is just the shortest way possible.
Yeah, so if it's shorter,
Easy
it's
way to-
minor, stuff like that.
that's the easiest way to remember.
Yeah, so like major, like a major scale. Yeah, I get it.
Did you hear what Allison just asked?
Wait, what?
Sorry.
Hey guys, did you hear what Allison just asked?
I did know that.
How do you know which way to go? Simple. Follow the letters. Go from L to J and J to N.
So it was L and J.
Okay, so check it out. What if I said this?
Oh, you could even.
It's just you. Yeah. No. You assume. Sit up. You assume that you're always going to take the minor arc. Okay. You assume that you're taking the minor arc. Go with me? So assume you take the shortest distance, unless it tells you to take the long distance. Okay. Y'all are gonna. That won't be confusing. I promise. It'll be easy. All right. Two arcs that have the same measure. By golly, here's our word again. Congruent arcs. Congruent arcs are two arcs that have the same measurement. In this figure, it says that ST and UV both have the same measurement. We don't know what it is. It's just called X.
CPCTC.
Oh my gosh. Oh boy. Yes, because clearly it's triangles involved here.
They're congruent though.
Alright. So, if you have two arcs with the same measurement, you have congruent arcs. Okay? Let's do a quick recap here. Make sure you get it, because this is the lesson in a nutshell. Good job, Mr. Robinson. Here is U,
V.
V, X. Okay? Let's make sure we got this down. If I said that, first off, is this a central angle? Is UVX a central angle?
Yeah.
Okay? If this is 37 degrees, what is the measure of arc UX? 37 degrees. Y'all with me? Okay? Make sure you get that, because it does change when we get chords instead of radii. Okay? We call these central angle measurements and the arcs that go with it. I don't know. You guys, you four, just call you out. Spend a lot of time on your phone. I guess it's an easy lesson.
Oh, it is really.
But I promise, I know it's easy, man, but I promise this time next Thursday, when you're done with this unit, you don't want to forget any of this, okay? Huh? Make sure. Ah. So, in a circle, or in congruent circles, first off, if you have congruent central angles, they have congruent chords. Second off, congruent chords have congruent arcs. And third, congruent arcs have congruent central angles. No, it's not CPCTC. Stop saying that. We're not dealing with congruent triangles.
Congruent
You were
parts
dry.
of circle things are congruent.
No, it doesn't fit.
Come here. Look.
No, it doesn't fit. I don't need to come over there. It's a waste of my time. Okay? Alright, let's talk about what this means, okay? Here's what this means, guys. This means that if you have congruent central angles, then you have congruent chords. If you have congruent chords, then you have congruent arcs. And if you have congruent arcs, then you have congruent central angles. You smell the transitive property involved, right? If one, if A, then B, if B, then C, if C, then A,
That's how we used to do that.
okay?
Wait, B, C, D, what, B, C, and
We
H.
pissed.
Alright? I'll come back to this one if y'all wanna write it down. First, I wanna apply it. I know that TV is congruent to WS. Find the measure of arc WS. If they're congruent, are they equal?
Yes.
So set them equal to each other. Once you set them equal to each other,
Work 'em out.
solve for your variable, plug your variable in, work it out. I shouldn't have to explain this, right? Come on now.
Wait.
I spent 6 weeks explaining this at the beginning of the year. Guys, if things are congruent, are they equal?
Yeah.
Yes.
Just go with it.
And some.
I'm not, you know what I mean? Not gonna go with it. Yeah, they are still similar. Okay? Alright. And, I've got congruent circles now. Circle C is congruent to circle J. C and J are congruent. Oh! GCD is congruent to NJM. What does that mean about the chords that are connected? Congruent. Got me? If you get congruent central angles, a la you see this symbol,
Oh, yeah.
that means that whatever is connected here also has to be congruent. So that's why 14t minus 26 would be equal to 5t plus 1, which I think they do on the next one. All right? You get a 3-minute break. Okay. In a circle, if a radius or diameter is perpendicular to a chord, then it bisects the chord and its arc. In a circle, the perpendicular bisector of a chord is a radius. All right? You don't worry about writing that down, but the next example that I do, you have to write down. So put your French homework up and start doing math. Okay? I want you guys to write down that entire problem right there. You better start writing. Step 1,
Oh, gosh.
you're trying to find N to P. This is really odd, okay? It's very, very odd, I know. But we're going to work it out. Alright. When you're drawing this circle, this is how it starts, y'all. It's going to start like this. Start, going to look like that. Bisect it. And it might tell you that that's a right angle. Then it's going to give you this information, 8 and 9. All radii are created equal. What is the measure of R to M? 17. How'd you get that? Okay, no it doesn't. It says R, 8, 9, M. Here you go, I'll help you out. R,
8 plus
M.
9.
8 plus 9 is what? Is 17.
Miss Hall's not
If-
question.
All radii are created equal. Okay? All radii are created
Is
equal.
that what that circle and the dot means? Yep, created.
No, it means circle. Alright? If all radii are created equal, then how far would it be from R to N? 17. How far would it be to R to P? 17. Okay? So this is 17. This is 8. Yes or no, I have a right triangle.
Yeah.
I now have a right triangle.
Now that you drew that, yeah.
And now I need to figure out, using the Pythagorean theorem, what x is. So I could go 8 squared plus x squared equals 17 squared. 17 is my hypotenuse, which means that x and 8 are the legs. If I work this out, will they work it out for you? Don't they? Yeah.
15.
64 plus x squared, is it 225?
Yes.
It's 225, subtract 64 from both sides. What happens when I subtract 64 from both sides? It's not 225. What's 17 squared? I only go up to 15.
Stop. Stop. I want to do.
289.
289.
289 minus 64
2 inch.
is 225. The square root of 225 is 15. Time out. The question asks you, what is the measure of N to P? Why would you say 30 and not 15? Look, X is 15.
You gotta plug.
But
You
you
gotta
gotta
plug
put it
X.
times two.
You gotta plug 15 in for X.
Very good, guys. Very good, very good. Everybody misses that at some point in time. Okay? The whole distance from N to P is 30. It's not 15. So when you're setting up this problem, make sure that you find X and then you multiply it by 2.
That was pretty easy right there.
Yeah, it's not easy.